Okay, let's look at example 4.1. In this example, we have this crane. A fixed crane has a mass of 1,000 kilograms and is used to lift a 2,400 kilogram crate. It is held in place by a pin at point A and a rocker at point B, and the center of gravity of the crane is located at point G. Okay, determine the components of the reactions at A and B. Okay, so for all these things, the first thing we're going to do, what's the first thing we're going to do? Well, we are going to create a free body diagram. So we have this crane coming off here, and here at this point, and here at this point. So what do we have? At point A, we look at this connection. What is that connection? It's a pin. So we have an unknown in that direction and an unknown in that direction. I'm going to call it AY and AX. Now at point B, this is just a rocker, so there's only one unknown, and it is in that direction, BX. And here we have the weight of this thing, 2,400 kilograms, but that is not the weight, that is the mass, so we need to multiply that by 9.81 meters per second squared to give us a weight. And just to make the picture pretty, here at the center of mass, you have the weight of the whole thing, which is 1,000 kilograms times, again, 9.81 meters per second squared to give you a value in newtons. Okay, so we want to find the unknowns A, B, AX, AY, and BY. So how do we do this? Well, with all these things, we have three basic equations. What are our three equations? We have our sum of our forces in X is equal to our sum of our forces in Y, which is equal to our sum of the moments, which is equal to 0. So you'll see me write it that way. It's three different equations, but it's the idea. So there's an easy one. We can do all three of them. We can do them in any order, but there's an element of just picking the order that makes the most sense. And right now, I can look at this and I can say there's only one unknown in the Y direction. So I am going to say, you know what? Let's take my sum of my forces in Y equals to 0. Well, if I'm going to do that, what am I going to have? I'm going to have AY minus the weight, which is this this number right there, minus this value right here, the weight of the thingy. I don't know, the load is equal to 0. So I'm going to put these on the other side. So therefore, AY is equal to 1,000 times 9.81 plus 2,400 times 9.81. So AY ends up being equal to 33,354 newtons. So we'll just call this, we'll say that therefore AY is equal to 33.3 kilonewtons. Okay, that's our first one. That was not too painful. Now let's look at our second one. We're going to do our sum of forces X, and we have our moments. Well, if we do the sum of the forces in X, we have AX and BX, so we're going to have two unknowns. Sometimes you just have to do that, but in this case, let's pick a moment instead. Let's say, hey, you know, if we take the moment about point A, what do we know at point A? Well, the forces at A are going to go through there, and so you're going to have no moment. So let's do this. Let's say, oops, sorry, this is jumping around a little bit. We have our sum of the moments at A is equal to 0. So what do you have? You have BX times that distance, which is what, 1.5, right? And that's going to rotate it, and it's going to come around in that direction. So, and if you notice, these other two are going to go in the opposite direction. So I'll just set those on the other side of the equation. Is equal to 1,000 times 9.81 times the distance, times this distance right here, which is 2, times 2, right? Plus 2,400 times 9.81 times 6, that distance there. And so BX ends up being equal to 107,256, or 107.3 kilonewtons. So that's BX. Okay, and then the last one is AX. Well, let's just do that. That's pretty easy at this point. You just say sum of the forces in X equals to 0. That's an X. So therefore, AX plus BX equals 0. So AX is equal to minus BX, right? So therefore, AX is equal to minus 107.3 kilonewtons. So, and there's our answer. So we found AY, BX, and AX.